In 5.3c, we're going to determine whether two events are independent or mutually exclusive. So let's define independence. What independent events are is the occurrence of one event has no effect on the chance of the other event happening. Now, be careful. Remember, mutually exclusive means two events have nothing in common. This just means event A cannot affect the outcome of event B. So there's actually a test that you would do to check for independence. If you want to see if A and B are independent of each other, what you do is you find the conditional probability of one with respect to the other, and then you reverse it, one with respect to the other. So let me show you. Here we have a get-rich example. A survey, we have 4,826 randomly selected young adults, 19 to 25 in age. They were asked, what do you think are the chances you will have much more than a middle-class income by the age of 30? This two-way table shows us the gender and the opinions if they're going to have a higher than middle-class income. So the question here is, are the events a good chance and female independent? So if we take a look at that, we're talking about a good chance and we're talking about female. Is there independence? That is it me being a female will not impact me of having a good chance? Or of me having a good chance, I will not be impacted by me being a female. Let's do the math and see if they're independent. If this formula and this formula holds, then the two events are independent of each other and that one will not affect the other. So I'm going to start by defining this as event A and this one here as event B. Now, for the first part of this formula, what I'm going to do is I'm going to do the probability of a good chance given that I'm a female. So right here, we're going to find the probability that we get a good chance given that we are a female. And then we're going to compare that to the probability of just A, which is the probability of a good chance. So what's the probability that I have a good chance? Now, this is not conditional. This is actually looking at the entire group of people. So for this one, we're looking at the 1,421 out of the 4,826. And that's about a 0.294 as a decimal. Now, how does that change? What if we look at this one here? The probability of a good chance given that we're a female. So given that we're a female, we are actually looking at this whole group and we want to know of the good chance. So for that, we are looking at the 663 over the 2367. And that right there is going to get me a 0.28. Now, because I did the first part of this formula and it actually does not equal, so they're not equal to each other, I do not even have to carry out the second part. So are these independent? No, there is dependence on this. And that just means the event or probability of me being female will impact if I have a good chance or not. Let's look at this allergy example. Is there a relationship between gender and having allergies? To find out, they did a random sample at this United States Census school, and they randomly selected 40 high school students who completed the survey. Here's a two-way table by gender and your allergies. Here's all 40 students. Are the events of being female and having allergies independent? So what we would do for that, for the test, is the first part of the test says, find this. I'm just going to define female as F and allergies as A. So is the probability of being female given I have allergies the same as the probability of being female? So if I look and find this fraction first, the probability I'm female given I have allergies. So I've given that I have allergies is there. The probability that I'm female would be 10 out of 18. Okay, what's the probability I'm female? Well, that's of the entire group. So for that case, we're looking at the entire group, and the probability you're female is going to be, therefore, our 23 out of 40. Now, if I were to simplify these into decimals, I'm going to notice they're not the same. Now, I do want to show you the other side of this test, though. Let's just reverse it. What I'm going to do is put A first and then F, and then this changes to A. So the probability that I have allergies given I'm female, is that equal to the probability I have allergies? So to do that one, let's find, again, probability of allergies given I'm female. So I'm just looking at all the females. The probability I have allergies, in this case, would be 10 out of 23. Now, what's the probability I have allergies? Well, everyone in the group, the probability you have allergies is 18 out of 40. So that would be 18 out of 40. These are not equal to each other. Therefore, again, we're seeing, are the events independent? No, they're not. There is some dependency among these two events. Now, I'll tell you, when we hit chapters 8 through 12, you're going to be asked a lot of the times if these events are independent. And once we hit that last topic in the AP Stats world, we no longer actually have to do the math to support it. It's just going to be obvious to us that one event will not impact the other, and we just have to state it in a sentence structure. But the book wants you to start to understand there is a mathematical relationship behind it that can actually prove it.